The loops are, how many loops are there? Just double of that 4. This is how question number 8th we have done. Now let me take 9th question. What does the 9th question say? Let me check it. 9th question says trace the curve r square cos 2 theta equal to this. This is hyperbolic type. I think yeah, it is hyperbola. Question number 9th here. Let me talk about it. It is r square cos 2 theta is equal to a square, and this is known as hyperbola. If I convert this into Cartesian coordinates, then you will just see it will be a hyperbolic formula. Solution. Let me just take the solution. If I replace converting this into Cartesian, converting it into Cartesian coordinates, to clarify that point, that r square cos 2 theta is cos square theta minus sin square theta equal to a square. This is nothing but r square cos square theta minus r square sin square theta is equal to a square. But r square cos theta is equal to x square, because we know that in polar coordinates and Cartesian coordinates, x is known as r cos theta, y we take r sin theta. These are the Cartesian and polar coordinates relationship. X equal to r cos theta, y equal to r square cos square theta. This is x square. This is minus y square is equal to a square. So what do we see here? So here we see, and if I just equate the lowest degree terms of this equation, x square equal to x square minus y square equal to 0. Okay, equating the lowest degree terms. Equating the lowest degree terms. Lowest degree terms of this equation to 0. Of this equation to 0. That means x square minus y square equal to 0, or y equal to plus minus x. That value is there. Okay, so this is what we have obtained here. So x square minus y square equal to, or x equal to plus y equal to plus minus x. There it means there are loops here. But there is a y equal to plus minus x, y equal to plus x, y equal to minus x. It means there will be a tangent lines of this kind, y equal to plus minus x, and y equal to minus x, y equal to plus x. These are tangent lines here. We will find out. So tangent lines of this kind will be obtained. Okay, so what kind of questions are there? Now let me talk about the values here. Theta. So at 0, at x equal to a here, if this is r is equal to, if cos theta is suppose 0, at 0 r square equal to a square, so r equal to plus minus 1. So let me take what is the values of this points here. So if I just solve the given equation, then what are the possibilities? So theta equal to 0, when theta is equal to 0, r square into cos 0 is equal to a square, or r square equal to a square. Okay, that means r equal to plus minus a. That means r equal to plus a and r equal to minus a. So at 0 degree, the value of a is this. Okay, r is in that situation, and r, when r tends to, theta tends to infinity, at at pi by 2 it is this value. At pi by 2 the value will be 0, because pi by 2 is 0, is not defined. Okay, so when r increases, theta is to r equal to plus minus a. Okay, so maximum value of r is a and minus a. Minus a is minimum value, maximum value is minimum and maximum value. maximum and minimum values of R, the reduced vector of R, maximum value and minimum value. If I draw the curve, now here R square is naturally, it will be symmetric to the pole here, even as initial line also, and it be symmetric if I find out. If be first point we just forgot about, if we change theta by minus theta and R by minus R, no change. The equation remains change. It means it is symmetric to both pole end. It is the equation of the hyperbola undoubtedly, for the x square minus y square equal to a square, with a as the maximum value of that. Okay, so if we change theta by minus theta, R by minus R, so the equation doesn't change. The equation of the curve does not change. Hence, the curve is symmetric. The curve is symmetric here about both pole and the initial line. This is one of the points here. If I draw a hyperbola like this is distance A here, A point is A0, here theta is 0 here. This is minus A, and here it is minus A. This is minus A and pi, 0 but pi here. This is origin, x-axis. Okay, and this is this axis, y-axis by this axis. In Cartesian coordinates, if I draw, then this is hyperbolic equation, or sorry, hyperbolic equation was there. And distance is A to this and minus A to this distance. This is minus A, and this is A here. A0 point is this. This is hyperbolic equation. So tracing of this curve will be of this kind. This is a hyperbolic equation. Then we just express this as x square minus y square equal to a square. Or a square, if I divide by a square, then x square from a square minus y square from a square equal to 1. Proper hyperbolic equation. And that hyperbola is expressed in this way. Okay, here distance a and minus a, as r is equal to plus minus a. If I take this into Cartesian, into polar coordinates, I mean. In polar coordinates, if I express, then f theta equal to pi. Minus a and pi, and a pi, that we have just taken. This is a hyperbolic equation. Okay, so this is O. This is tracing of the hyperbolic equation. So this is hyperbola here. Question number 9th we have taken hyperbolic equation. Now let me lemniscate Bernoulli. This is 10th question now. Okay, so this is 9th question. We have just traced the curve of this. Now let me take the 10th question. This is question number 10. So this is Bernoulli's lemniscate of Bernoulli. 10th question is. Let me talk about that also. Now question number 10. Lemniscate of Bernoulli. What does it say? Question number 10 here. Here it is. R square equal to a square cos 2 theta. This is known lemniscate of Bernoulli. Bernoulli's lemniscate of Bernoulli. Lemniscate of Bernoulli. Okay, so this R square equal to A square into cos 2 theta. So there are some fixed figure of them, but let me first explain this. Again, theta and R changed, replaced for the solution. If we change theta and R by minus theta and minus R, theta and r by minus theta and minus r, the curve is not changed. The equation of the curve does not change, or it remains unchanged, does not change. This means the curve will be symmetric. The curve will be symmetric about the pole and initial line, about pole and initial line, Okay, so if I put r equal to 0, then it will find out what are the different values at which the tangents will be there. So that let me find out. So question is here. So what is Bernoulli's demonstrate? Let me put here r equal to 0. This is first point. Second point, r equal to 0 implies that cos 2 theta is equal to 0, and 2 theta equal to, because cos 0 is for pi by 2, 3 pi by 2, 5 pi by 2, 7 pi by 2, etc. That means theta equal to pi by 4, 3 pi by 4, 5 pi by 4, 7 pi by 4, etc. At these points, tangents will be there. Pi by 4, there is a tangent. At 3 by 4, there is a tangent. 5 by 4, there is a tangent. And 7 by 4 is there tangent here. So, that point that we described. So, what is the curve here? And if I differentiate it, then maximum value of that curve can be obtained. What is value of maximum value? If cos 0 is there, at 0 it is r square equal to a square. At 0 degree, and at theta equal to 0, r square equal to a square, at r equal to plus minus a. At 0, it is plus minus a value. If I put theta equal to 0, theta equal to pi by 2, not pi by 2, I'm sorry. These values, this is not sin 0, I'm sorry. Not, it is at 0, cos 0 is 1 here, this is 1. But 0 degree, if theta is 0, then cos 0 is 1. We are at that r equal to plus minus a. Theta equal to 0, r square equal to a square, or r equal to plus minus a. At theta 0 degree, r is plus minus a. That means we have to just describe that figure, or if we differentiate, then also we can find out the value, but no need of differentiation. That figure is, that we express that figure. Now this is of Bernoulli's spiral. Okay, Bernoulli's spiral is of this kind. Here it is pi by 4, as we say 7 pi by 4, and here it is 3 pi by 4. This figure will be of, this is 3 pi by 4, 5 pi by 4, is 5 pi by 4, 7 pi by 4 and 5 pi by 4. Okay, and this distance is a here, is minus a to this side. If I take it as pole here, if I measure a, there is minus a distance, this point is at pi. Okay, this is at pi degree, this is a minus a and pi, and this is a and 0 at 0 degree. So this is x-axis we take, or the initial line we can take, this is y-axis. Between these two lines there is no, or it will be negative within this period. The value of this will be negative during this period, because then the curve will not exist. How do we find out this value? If I just take theta, you are taking pi by 2, at pi by 2 it is pi, so negative value will be there. Okay, at pi by 6 even, it will be negative value. So pi by 4 is tangent. After pi by 4 to 3 pi by 4, there will be no existence of curve because r square will be negative in that situation. Because it is negative, then r square will be negative between pi by 4 is lesser than theta is less than 3 pi by 4. This is so. It means within this period, the theta r square will be negative. That means no curve will not exist between this. Similarly here, 5 pi by 4 to 7 pi by 4, the curve will be, r square will be negative. So the curve will not exist. The curve will not exist. Between the range this 5 by 4 to 3 pi by 4. This is what we similarly 5 pi by 4 to 7 pi by 4. This will be negative here. R square will be negative. Value of cos pi will be negative during this period. Okay, this is 5 pi by 4 and 7 pi by 4. Theta value is. So this is what we have taken here. Okay, now let me. If theta is this 5 pi by 4, then this value will be negative from this period to this. This is just obvious. The curve given. This is question number 10th we have taken. Now let me talk about 11th question. What does 11th question say? Let me check it. Question 11th is trace the curve r square equal to a square, a sin square theta upon cos theta. Question number 11th is r is equal to a sin square theta into cos theta. Okay, now if I multiply this by r or by r, then what is multiplying by r solution? And we convert this into Cartesian coordinates. Multiplying both sides by r. Let me write here both sides of this equation by r. So we get r square is equal to, okay, and if I write here, no r is there, and this is upon solution. Here, r equal to a sin square theta upon cos theta, and it can be written as a into r square sin square theta upon r cos theta. No change, only one r is there. So we have multiplied by r in both sides. This is r square upon r means single r is there. Okay, so we have multiplied by r only. Now converting this into Cartesian coordinates, so this will be r square is equal to, this is a into, this is y square here, upon this is x equal r cos theta equal to this, and r square is x square plus y square, we know about. This into x is equal to a y square. Okay, so converting them into Cartesian coordinates, converting it into Cartesian coordinates, So this is what, this is x here, r cos theta is x, r sin theta is y, so it is y square because r square sin theta is there, and r square is not x square plus y square, because if I square these values, where r is equal to, x equal to r cos theta and y equal to r sin theta. R sin theta. If I square them and add, it will give us y equal to r sin theta. Okay, it will give us x square plus y square equal to r square common. In bracket will be sin square theta plus cos square theta, which is 1. Therefore, r square we always keep x square plus y square. We convert that into Cartesian coordinates. Therefore, r square this is 1. Sin square theta plus cos theta is 1. So r square equal to sin square plus cos theta. So here r square is converted into Cartesian coordinates. Now it can be solved further. It can be solved for y here, because the value of y. So if I've now converted this into Cartesian coordinates, we can trace the curve in Cartesian coordinates. The same curve will be there. The curve here. If I multiply this is Cartesian coordinates. A by square with a loop here for equating smallest degree term, equating the smallest degree term of this equation to 0, equating the smallest degree term to 0, smallest degree term to 0. That means this a y square or y square equal to 0, y equal to 0, y equal to 0. It means coincidental tangents are there. It means the cusp type of question will be obtained. There will be a cusp here. So, cuspodial, the question will be of cusp type. Now, if I solve it for y, then what it will be? Now, so there is a, because coincidental tangents are there will be a cusp here. So, cusp, the shape of the curve will be of cusp type. So, cuspodial, cuspodial type of curve, curve will be there. Cuspodial type of curve is there. Okay, so if I just find out those values, so if I just further solve it, this equation, this is a by square here. If I take this to this side, so by square, if I take common, it will be x minus a, or a minus x equal to x cube. Okay, this is a minus x here on top. This is a minus x. A minus x equal to, so by square equal to x cube upon a minus x. So if x is greater than a, okay, minus 2a, minus 3, this is 2a, 3a, 4a. Beyond that, the curve will not lie, because y is negative. Here, if x is greater than a, x I put greater than a, then y square will be negative. Y square will be negative. Imaginary tangents are there, negative. So there will be no curve. Curve will not exist. So curve will not exist. Will not exist for x greater than a. It means x beyond a, x equal to a is the asymptotes here, and x equal to, so x equal to a is the asymptotes here. Is the asymptote here, because beyond that the curve is not lying. Okay, curve will not lie beyond that value. That is what we have to discuss about. No, let me now draw the curve. What will be the curve there? Then it is a cusp type of equation. Here this is a, suppose if I take this is x equal to a here. So from this is cuspodial or cusp type of curve here. The same type of curve must be there. This is okay. So cusp type of curve. This is the first species of curve here. First species of cusp. First species of cusp we have taken at x equal to a. Okay, this is dotted line, because it is not possible that this y tends to infinity. Y tends to infinity. This is x-axis. Y-axis if I take O, y dash x, x dash x. So I converted that into Cartesian coordinates, and then I have drawn. Trace the curve. This kind of curve will be obtained. This is a cusp type of curve. and x equal to a. Beyond a, there is no curve. Curve will not exist beyond this because it is where x equal to a is the asymptote here. Asymptotes. Okay, this is asymptote here. This is the tracing of the curve. 11th question here we have done. Okay, so 11th question is done here. Now, if I talk about 12th question, let me talk about that also. What does 12th question say? Let me talk about this. Question number 12. Is r equal to 2a cos theta? Here it is r a equal to 2a cos theta. Now this is circle type of question. It is a circle here, it says. Okay, so now let me take what are the values of this. If theta is converted, the curve will be symmetric to the initial line. First point solution, let me take it. The curve will be symmetric. The curve will be symmetric about initial line. About initial line. Sorry, initial line. Sorry. About initial line. Why? Because if we replace theta by minus theta, there is no change in the curve. As replacing theta by minus theta, okay, will not change. The curve will not change. The curve. Therefore, the curve will be symmetric to the initial line. This is one of the points here. Now let me find out that what are the values then. R equal to 0. If I put, now putting R equal to 0, so we get cos theta equal to 0. Cos theta 0 is pi by 2. Theta equal to pi by 2. Okay, that is pi by 2. Then 3 pi by 2, 5 pi by 2, 7 pi by 2 only. The values are this. So theta will be 0 at these points. So it means these points are given here. R equal to a cos theta. R is equal to 2a cos theta. It was equation of the circle here. Okay, so R equal to 2a cos theta is the equation of the circle. Now, for the equation of the circle here, what the maximum value of this? If I find out at this point, so the equation of the circle is this kind. This is x-axis. This is origin by x. Let me take by s as x-axis. Initial line theta angle. If I take theta angle like this, it is the equation of the circle. So at different values, pi by 2, sorry, at 0 it is twice a. Maximum value is twice a here. At 0 degree theta is 0, so r is twice a. It means it is circle like this. This is twice distance. A center here, a0, but it is twice a0. Okay, this is a circle here at which, if I take this is theta angle, this is theta, at theta angle it is r and theta, where r is this value, r theta, if any point is found out. Because at 0 degree, we have taken 0 degree here, it is twice a. Maximum value of this curve will be at 0 degree. At 0 degree, theta is 0, r is equal to twice a maximum value. So this is the total distance. First point is this. Then we take the points here. In terms of a, the value will be obtained. So what are those points? Then they can be down here. At pi by 3 the value will be there 1.2, that means A. At pi by 3 the value is A here. Oh, sorry, it is A like this here. Okay, because A is the distance, so it is pi by 3 here. It is A pi by 3. A point here pi by 3. Then at pi it is minus twice A. Okay, it is minus twice A here. At theta equal to pi, if theta equal to pi, total minus twice A means from this point, initial point I have taken, this is distance minus twice A. That is the point here we have taken. So this is passing through the origin, but okay, symmetric to the pole also, and sorry, symmetric to the initial line. Initial line above and below the curve will be same. This is the equation of the circle here. Okay, so cos 2 theta. Sorry, this is cos theta here. Twice here cos theta. This is the circle. Equation of the circle is this. Okay, so this is question number 12 we have done. Okay, so next question 13th, 14th, and others. I'll take after 5 minutes. Okay, after that let me take some more steps here, replacing the marker, etc. Okay, see you then after 5 minutes. 13 questions and onwards, I'll take those questions there after a certain time. Okay, see you after 5 minutes.